So we're going to switch gears real quick, and we're going to talk about a few, well, rather important topics with regards to your code organization and the various things you need to keep in mind in order to effectively maintain your code, as well as figure out where things go wrong and when they go wrong. And so, in particular, we need to discuss in some amount of detail, not extreme detail, and certainly not. It's not something I'm going to be directly testing you on, but there will be aspects, and I'll point out what those are that you will need to understand, and it's not necessarily having to do with the compilation, but rather just what your code expects and when. But again, I'll point out the things that will be relevant, say for an exam or whatever. And then but it turns out that this compilation process, or in general, when we're working with large code bases, we're going to be dealing with multiple files, right? It's going to be inevitable, as Thanos would say. And so there are various concerns that crop up as a consequence of having multiple files in C++ going through its compilation process that we need to be aware of in order to actually be able to do anything useful, as we'll see in some examples when we get there. But anyways, let me go ahead, before we even talk about any of this, let me just point out a few things. So let me go ahead and open up my IDE. And so we're not distracted. I don't know if I need this, but I'll throw up anyhow. In fact, I'll just expand this out. So, oops. So here I just have some code. I'll throw this up on Canvas so you have access to it too. Nothing too fancy. I have a function foo. It just prints out to the console fooey. I have another function foo sub a, which takes an integer x as a parameter passed by value. And then this is simply printing out the value that's currently, well, whatever we pass into for x, we add 1 to it, then print that to the console, end line. And then in main, I'm calling foo sub a, and then there's a couple other things going on here, which doesn't really matter. And so a few things I want to point out, right? And so first, let me compile this to convince you that it works, right? And so there it is. We see that this invokes fooey, this invokes 2, and so there's no new line here, and so just the 2 printed out from the 1 immediately after this, although I guess I'll throw it in there just to kind of, for my own sanity's sake. But regardless, it compiles, right? And so now a few things I want to point out. All right, so first of all, let me break this and analyze how it's breaking and why it's breaking, right? And so let me go ahead and say, let me just delete this. Boom, gone. And so clearly that's an issue, but why is it an issue? And so in particular, if we just parse this on our own, we see that, okay, so this is fine. This is just a function definition, right? And so this is going to do whatever it does once we call it, right? Again, function definitions in themselves do nothing until you invoke it, which will be done here. Okay, so the first problem we should identify is that we see this, but at this stage, I don't know what this is, what this name means, right? And so if I were to try to invoke this, I have nothing that I can invoke. So this is something the computer will clearly not understand this, right? It's trying to make an attempt to call something that does not currently exist. So this is will be a syntax error. And so the way to convince ourselves of that is, let me compile. And so clearly no. Let me go ahead and expand this up a bit. And what I want to point out here is this. And if this isn't, let me see if I can, right, and so expand this up. So what I want to make note of is the C in front of the error code there, right? So clearly the description is going to be the more useful thing to you, but just make note of the fact that this is a C. And so this is saying the computer simply does not understand what you're trying to do here because, well, such a function doesn't exist. And so, okay, keep that in mind. Now let me go ahead and bring this back. I'll bring back the definition or the function foo, but now instead of this, I'm simply just going to do this. And so we are familiar with this, right? This is the function declaration or a prototype. And the reason we would do this is it would, well, presumably along with its definition, it would provide us more flexibility with the organization of our code. In particular, let me do something just to illustrate that before we move forward with the actual example. So let me bring everything back and say, for example, I do something silly like this. Well, being so limited, there's really not a lot I can do that's gonna be meaningful. But let me, well, foo and food, so nothing here is meaningful. So let me do this, and then let me also do this, right? And so here we have a bit of a cyclical relationship in terms of the function calls, right? And so clearly at this stage, this won't work because I don't, at this point when I parse this, I don't know what this is, right? There's a function call apparently, but I don't know what that is because that has not been defined yet. And so typically what they do is they say, well, what we can do is, well, let me go ahead and just create this, put this here, and presumably I think they would have just told you that this is enough to let the compiler move forward. And what I like to say is this is the declaration or prototype, as I mentioned previously. And so this is reserving effectively that this exists. And so this is enough to let the compiler know that it can do this. Now, when it actually goes to invoke this down the line, it will actually need to know this. But the thing is, it turns out that this doesn't need to be here. This can be someplace else. This already knows about foo, so it doesn't really matter. In fact, this will actually break things because it'll just continue calling each other. So let me get rid of this because it doesn't really matter. And I can move this anywhere I want, or I can move this down here, right at the bottom of the my file. But again, it doesn't matter where I put it. And so put it back here. And so the example I like to bring up that sort of highlights what this is versus what this is this idea of going to a restaurant, but rather just calling a restaurant and making a reservation, right? And so I call whatever the taco place. I'm like, yeah, I want a reservation to come eat tacos, right? And so clearly the establishment of the reservation does not require myself or the definition of me, right? It just requires effectively my name and maybe some other information with when I'm going to arrive, right? It isn't until the point of time in which I will be at the restaurant eating in which I need to know me or the definition of me, right? So effectively, the analogy here is that this is kind of like the reservation, making a reservation to the restaurant. This is actually me at the restaurant eating, right? And so it's very loose, but just kind of maybe that example might help you out. And so now given this, right? And so let me go ahead and keep this here. Let me get rid of this actually, right? And so what I did was I kept the reservation, but I got rid of the definition. And so effectively when I try to call me to eat the tacos or to arrive at the restaurant to eat, it's not going to know what to put here. There will be no body to place in this location to eat the delicious tacos, right? So let's see what kind of error we get when I do this. Now we compile. And so error clearly. And so let's go ahead and take a look at this. And so this is a bit different. So before, when we had the issue in which we simply don't understand what's being done, we had a C in front of the error code. Here we see that there's something called L and K, right? And so this hints at a different type of error relating to, well, kind of seemingly the same thing. We just don't know what function is being called, right? Not quite. And so just keep that in mind. There are two regions where errors can occur, and they have to do with subtly different circumstances, right? And so just let me go ahead and turn this off, right? And so now that is to say, it's not breaking because of this in and of itself, because it understands this. It understands that such a name exists, and it's able to get past the initial phase. The computer understands this. It's just when it goes to actually have this individual do something like eat the tacos, it can't do it because there's nothing here to provide this substance, right? And so keep that in mind. We'll come back to it in a little bit, but while we're here, I want to point out a few things, right? And so in particular, up until this point, I'm sure most of you have already seen this sort of syntax, right? The sharp include whatever. So in this case, this, and this, and you have a bunch of other files from which you're calling functions. Like say, if I wanted to call foo sub b, and foo sub b is defined here rather, right? So if I have foo sub b, let me go ahead and just show you everything, right? Here's foo sub b's declaration, right? And then here's, I'm missing, oh yeah, I got rid of it. So, Solution Explorer. And so, and here's foo sub b's function implementation. Close this. Let me move this over here. In fact, I'll show all three. So boom, right? And so if I want to call foo sub b in main, and I don't need these breakpoints, I need to. So if I uncomment this, right? Again, so we have the problem where we can call this. Let me bring back foo sub a actually. I forgot what it was, but void foo sub a int x, I believe it was, and I think all I did was I printed out x plus 1, and then home row. I think this is enough. All right, something akin to this. It doesn't really matter. Okay, and so now if I want to call this function, I need to provide, well, minimally the name, right? So I can go ahead and do that. Let me go ahead and include that, which is in this file, right? So b sub h. This will give me the ability to reserve, well, this will reserve the name here. This will allow me to call this, right? And then presumably when we actually do this, it will populate this in terms of its functionality. Right, so let me go ahead and compile this and make sure this works. So I brought back the definition of foo sub a, and so that will resolve this particular issue, which I'll talk about in just a moment. So boom. Okay, and so now there's that. And so the reason we do this is, well, not so much a reason, but one of the things this affords us is that if you're writing libraries, putting all the function declarations, if we're just talking about just procedural programming, this will allow the user to have enough information to use your code, and then presumably, and if you have the implementations in a separate CPP file, that will effectively, in a certain sense, hide the implementations from the user. Well, yeah, they might have it, or you could compile this into a library, which is going to be, in a certain sense, not encrypted, but in a format that's not really readable. But that's all besides the point, right? So generally speaking, the header files are the things that users will interface with if we're talking about C++, and then the source files or will be the things that are effectively hidden from them in some way if you choose to create a library out of it. And so we're doing this for functions now, but the same thing holds true for classes and objects as well. Meaning I would put the class definition in the header file, which we'll see later on. I think we saw a bit of it last time, or I at the very least talked about it. And then we'll put the actual implementation for the member functions here. And if we have time, I'll go through an example. If not, I'll just make a separate video, or we'll do it for office hours or something. But regardless, point still remains. This is generally the idea behind, well, one of the things we'll be doing with multiple files. With all things you create, whether it is functions or classes, and we'll see more examples, and that'll sort of solidify things hopefully. And so now another sort of issue I want to bring up is like another similar issue in which remember when I removed one of these foo functions. So if I deleted this, we'd have the same issue, right? Let me delete this, and it would have the same linker error. No, I think you guys can see this fine, right? So unresolved external. So effectively, this is saying it can't find whatever this should be in terms of its behavior, right? Because I got rid of it. Now, if I do this, and then, oops, not foo sub, do this, but then also do this. Oop, no, I keep on, I want to do this, right? Or rather, this, or it doesn't really matter where I put it, right? So this, so here I have two foo sub b's, right? And it doesn't really matter if they have the same implementation or not, or I could get rid of something like this right now. Let me make this 5. It doesn't matter. It's all besides the point. And when I try to compile this, we see that there's going to be another one, right? But in this case, it's the same LNK, but it's saying multiple definitions, right? So it doesn't know which one to choose, which it should make sense, right? If you have the names of objects and you have 2 of them, which one do you use? And if you're a computer, you don't know which, right? You can't make assumptions about which one is quote unquote correct or right within any circumstance because, well, it's just not that clever. And so here's another form of LNK error, not related to not knowing what the name is, because we know the name. It's just that we don't know which of these is attached to that name, right? And so a bunch of different things. We're gonna hopefully understand what all this means in a little bit. So just bear all these things in mind. One last thing before I leave this, let me go ahead and get rid of this because it's an issue, right? And so I want to highlight exactly what this is, or what it's doing for you, and the only thing it's doing for you, right? And so let me go ahead and do something pretty basic. Let me delete this, right? I deleted that ending bracket for this function. If I try to compile this, it should obviously break because that's clearly a syntax error in terms of bracket mismatch. But again, to convince you, boom, broken, and then there's a bunch of issues, right? Mismatch brackets are very difficult to debug because it breaks everything, right? And so the error that you get isn't necessarily relating to, well, the issue. It's just it's so many things are broken. It's just choosing something and telling you, well, this is wrong, but it's hard to determine exactly where it is. But regardless, here's what I'm going to do. I'm going to create another file, a header file in this project, new item. I'm going to call this, it's going to be a header file. I'm going to call this never do this.h. Okay. Oh, incidentally, in the default templates for creating projects in Visual Studio 2017 and above, they like to throw this in here. for this class, and I'll make note of this in the specification for the projects, delete all instances of these. Okay, it will break my testing. And so this is actually doing something useful. It's just that we're going to replace it with something, well, not so much better, but something that is, well, one, won't break my testing and is actually part of standard. It turns out this is not yet, while there's a lot of argument for it to be folded into standard, but it is not yet folded into standard. And so we will be talking about the thing that is part of standard that serves the same purpose in a little bit. So, but for this class, for me, for now, delete all of those, because again, it will break my testing due to the way my folder structures are. So here's that. Okay, so never do this. And the only thing in this file, right, so zoom in, only thing in this file will be this closing bracket. Let me save it. Okay, there it is. Then we go back to main. Then we go back to where I deleted that closing bracket. Let me go ahead and say sharp include. Never do this. Now, pause the video and brainstorm a bit and think whether or not this will compile. So, let's see. I'll run a Control F5 in Windows if you want to run without debugging. Boom. It compiled and it ran just fine. And so what does that tell you? Sharp include does, and only what it does. It simply takes what's in this file and copy paste it exactly here. So effectively, every time you see this, you're taking what's in this file and putting it in the file in which you're including, at the point in which you include it. Right, so that actually ends up being extremely important to understand, right? It doesn't throw it like anywhere. It throws it exactly where you do this. And so there's some implications here that might not be apparent, but we will discuss all these issues when we get to the slides. And so anyways, let's go ahead and get there. Let me clean this up. Don't ever do this. There's much more clever ways to get fired. Don't get fired for doing things like this. Unless your whole point in life is to write obfuscated code, right? In fact, there's competitions, a C competition, where you submit code that is so unreadable. Well, it's the most unreadable code, but also not only that, but the most beautiful obfuscated code, right? And so at some point, remind me, I'll show you some examples. There's a yearly competition for it. It's pretty awesome. So anyways, let's go to the slides. Okay, and so compilation. So let's take a look at a bit of an infographic, right? And so this is what you have in your folder or in your IDE inside your filters, right? And so you have a bunch of header files, and maybe in each CPP file, it sort of includes those files in some form, right? And so, and again, if we were talking about classes or functions, these would have the function declarations or prototypes, or if it's a class, the class definition, and within, presumably in the corresponding CPP file, we have the function implementations, right? And so maybe there's a class A here with its implementations here, class B here with its implementations here, C, and so on, and maybe some other header file with a bunch of other constants or whatever here. And so this is what you might have in your directory or whatever. And so when you tell the compiler to compile, it turns out that before it does anything with regards to the actual compilation process, it will actually go through and resolve everything with the pound or the hashtag, right? And so these are called preprocessor directives. And so it will effectively go through and will, if it's an include, it will replace the includes with what's currently in the file, right? And so if we have include a.h in this file, at some point it will take all the code in a.h and paste it into this file at the point of the inclusion. Same thing with all of these, right? And so if B includes A, B, and C.h, it will copy paste all three of those files into this one. And obviously that will lead to a larger file, right? So a larger CPP file after you do that copy pasta process. Now there are other directives. We'll talk about that when we get to the slides, but generally speaking, at this stage, all preprocessor directives are resolved, right? Everything with the hashtag. And again, this will necessarily create a larger file, which has some implications when you're dealing with large code bases. We'll get there. And so now, after you have the larger file, this what we call the compilation unit, it will then be compiled for syntax, right? The compiler effectively checks each line. It parses it to ensure that it understands what's going on, or rather, it can translate the high-level language into, well, what would be the into the instruction set architecture, and thus ones and zeros, the object code. And so it'll go for that process and create a thing that is more something that the computer can understand than this. The thing I need to point out here is these streams up to this point are completely parallel, right? And so what I'm trying to point out here is that this does not need to know anything about this, or this, right? And so if a.cpp, this particular bloated file, is calling, it might have, well, let me do this since the arrows are sort of, so b.cpp might call a function from a.h, right? And so at this stage, all it needs to know is its name. So for syntax, you just need to reserve the name, the function header or the class definition, right? And so at no point is this looking at this at all throughout the syntax. Compilation is, you only need to know the name of things. You don't need the thing itself, right? And so that is to say, this is where the C errors come about, right? So if I did not define the name or reserve the name that it's trying to call inside the source file, then there's a problem, right? That will result in a syntax error because the computer won't understand. That's kind of like when I deleted foo entirely, or the foo declaration. Whereas it isn't until we get to this stage, this linker stage, in which these independently compiled compilation units are linked together to see where those function calls, or what those functions called should be doing, right? And so if b.o or b.cpp is calling a function from that's defined within a.cpp, it is at this point in which it will try to link together the definition of whatever function that is, foo sub a, and do it here. If it can't find the definition for foo sub a inside this a's object code, or anywhere else for that matter, you'll get a linker error at this stage saying I can't find the behavior for this function call that we find in this file, right? And so, and similarly, if we have foo sub a defined here and here, or wherever else, at this stage it will be confused as to, well, which one do you want to use, right? And so 3 main phases: the preprocessor, which executes or evaluates all the hashtags, right? So this is the Twitter phase. This is the checking for syntax, right? Making sure the computer can understand what you're telling it. And minimally, you only need to know the names of things in most circumstances. And then after each of these are independently compiled for, I guess you can loosely think of it as grammar, although people will shoot me for saying it, but the syntax, right? The understandability of your code by the computer. And then after that, things are then linked, in which you can, again, encounter the common issues in which you might not have a definition, or you might have too many definitions. And so, yeah, be aware. You don't need to master this concept, but you do need to have some semblance about the fact that there's 3 phases and things can break at different regions. And so we're going to spend a whole lot of time talking about this preprocessor phase coming up next, but everything else is obviously very important, because if you don't know, well, first of all, if you don't know if it's a linker error, then you might have some issues with regards to how to identify the bugs, and vice versa with compilation errors as well. So anyways, keep that in mind. I'm not going to specifically test you on the compilation process, but you kind of need to be aware of it at some point. There are some sort of indirect things that will come from this in terms of what I will expect you to know, but not this directly. I'll point out those when we get there. Okay, and so let's talk about a few etiquette, right? So first of all, just for now, even if you have some question as to why we need to do this, I'll talk about why later. Just know that, take my word for it, you have to do this. There's nowhere in the universe in which you have a large code base for any company in which you're working with one file, right? Never. It will never happen. Is virtually impossible. Excuse me. Virtually impossible to maintain such a code base. I don't know. I'm just trying to. I can't even think of a meme example where you would just have one file with 500 million lines of code. It just doesn't happen. And so we'll talk about the reasoning later. Just be aware that you do need to be able to learn how to work with multiple files, which you'll get exposure to in this class. Okay, and so first of all, we have multiple files. We have sharp includes. You never want to include a source file into another source file. That is just asking for linker errors. In fact, I almost guaranteed you'll always have a linker error if you do that. So never, ever do this. There's no circumstances, even in a meme sense, in which you do this. And so what do I mean? So if I have a file.cpp that defines some function, in this case it just prints out a lie, and then I have another file which defines another function and it calls some function, never do this. Never ever do this. For anything more than like the most simple of projects, and I'm talking like hello world level simple, this will always break. And so what you'd want to do is you want to separate, create a prototype for some func, put that in the header file, then include a header file here, right? And so that's the best practice way of doing it, but it's really the only way of doing it. And so yeah, please don't do this ever. Never ever include CPP files. It's depending on how much code you're working with, it's just sometimes you just miss it and it's very difficult to identify. Right, so just right off the bat, something you know for a fact that you will never do is this. Okay, and so now here's another one. This is going to be a bit more surprising for a lot of you. Never put using namespace std or any other type of namespace in a header file. Now, what does that mean? Right, and so have a header file, right? So some header.h. In doing this, it's actually really bad practice, right? And so this is called namespace pollution. Effectively, again, so the header files are the things that people are interacting with, and so they're going to take the header file and throw it into the places in which they want to use that code. Now, if you're throwing a sweeping namespace inclusion there, that's forcing everyone to use that namespace. Now, again, like if you haven't worked with namespaces, it's kind of like, well, so what? I only ever use standard namespace, right? It turns out there can be multiple namespaces, and as you start working with larger code bases, there's going to be a lot of different namespaces. And so a common scenario is that you might have, just for, in terms of the ability to quickly swap out code, I might define different namespaces with this identical functions, right? For example, I might have a different console interface, right? And so I might use cout. Right, and so I might have the standard namespace with the standard cout, but sometimes maybe I want to go to a different console with my own cout, but I don't want to go through and rename cout to some other function. Why not? Instead of that, I can just say, instead of using the standard namespace, use my namespace in that code base, and every instance of cout will now utilize my version going to whatever console code that I have implemented. Right, and so that is to say, you will maybe, again, so it depends on the organization of the code base, but you may encounter situations in which you have different namespaces, and if you force people to use that namespace, that prevents them from using all other namespaces, which is in general just a bad practice, right? And so yeah, don't do this. Now it's excuse me, I even have a hard time even saying this much. If you really want to, you can put it into the CPP files. I mean, this is reasonably acceptable, but you can do better than this, right? In fact, in terms of just trying to refine the way you think about your code, another way is, and so you saw some of this within this here, right? And so instead of saying, well, here, so include IOStream, right? I just, within the functions, instead of saying, well, using the entire namespace, I'm only going to call directly from the standard namespace the functions I want to use. And so this is the most fine you can get in terms of the resolution of control over your namespace usage. Now, this actually is kind of the far extreme of what I was kind of talking about, to the end that this is actually forcing whoever's using this particular source code to use standard namespace. Now, what I can do is I could say, well, I could say using std cout, oops, right? And so this would provide per file, this file in particular, the usage of this version of cout, right? So boom, I can get rid of all of these now. All right, so let me go ahead and do that. Let me do the same thing for endline. All right, so now, given that this is defined at the top of the file, I now have the ability to use standard cout, standard endline, without this. Boom, 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 and now, yeah, so everything still works, right? And so, and also, you could also do it like this. You could take this and move it per scope, right? So I can get rid of this and paste this in here, and so this would restrict this standard usage into this function, and so this would work just fine as well. Now, again, these are cartoon examples, so it's like not a lot of code going on here, but you can imagine having, like, maybe if I have a source library that has maybe 50 functions and only one of them uses the standard cout, then maybe I might just do this for that function. and maybe the others use different versions, right? And so, and what I was talking about earlier in terms of like hot swapping, well, not hot swapping, but swapping out different namespaces. Again, like later on, like suppose I do this, and this would presumably, well, not presumably, it does have each of these functions invoke a cout and nline. This is saying that the version they're calling is from standard namespace, but later on I might have a different library, right? Like maybe I have my own function, like you know, some sharp include. No, well, this is if it's my own, right? So, the difference between angle brackets versus quotations is essentially this will pull from the system headers, like the system path. This pulls from the current working directory, right? And so, just that's the only difference between that. So I might have, so I don't know, custom IO, although I don't have anything here. So then here, this might be calling from CIO, right? If that's the namespace for this. And then this would effectively swap out all of these couts and nlines to this version, right? So this is one application for this particular idea. But generally speaking, yeah, never include entire namespaces within your source files, or header files rather, because again, that's forcing everything that uses this, which presumably will be a lot, to use that namespace, which is, it might not be true. And as you become more advanced and encounter larger code bases, it is generally the case. And so another thing, never assume that a header file will include something for you. And so this is getting towards more best design practices, in that part of this, so the first part of this is never only include the things that you need when you need it effectively. And so this is part of that particular credo. And so let's suppose, for example, I have a class called alcohol. And so boom, inside another class, student, it looks like I have a student define 5 bottles of alcohol. And so a few things here. So I'm defining a array of alcohol, identifier bottles. We know that this will necessarily require me to call the default constructor for alcohol, well, 5 times, but that's besides the point. I need to invoke the constructor here. That is to say, I need to know what alcohol is to even define 5 of these things, right? Hopefully that makes sense. And so because of that, that means student requires the definition of the alcohol class, right? And so that means for us, because the definition of the alcohol class is in alcohol.h, ergo, that means we need to include alcohol.h. Okay, so I'm just sort of tying in this idea of where the definition is and when it's required, right? So if you need something from an object, you need to know the object. That is to say, you need to know the object's definition. And so the convention we're adopting in putting definitions into header files, that leads to making the statement, we need to include the header files when we do things like this. Okay, and so by way of what I will test you on is effectively when you need to know when you need to include a definition of something. And the short of it is, you need to include the definition whenever you use it. Right? That is to say, you don't need to know the definition if you're not using it, right? And so we'll see some more examples. Again, that was just a bit of an aside. We'll get back to this example now. So now main.cpp, and so here I am in main. I declare a student Larry. This will make an attempt to call, or will call the default constructor for student. I declare a vodka or an alcohol vodka, and again, this will invoke the default constructor for an alcohol object. Thus, both of these cases, I require the definition for both a student and alcohol. Now, I see immediately I do have, again, assuming that our convention, and it is, that we have the class definition in the header files, I do have the definition of student in student.h, right? I get that. Now, the question becomes, do I have, well, rather, if I compile this, will it be syntactically correct? The answer is yes, because I had made the assumption that student will always have alcohol defined, right? So if we parse this, again, remember, sharp include is copy pasta. So if I copy pasta what's in student.h into this file, we see that we would copy pasta alcohol.h along with the student definition, and then we would resolve the alcohol.h inclusion with its definition, right? And so at some point after the preprocessor directives are resolved, I have both the student and alcohol definitions within this main.cpp, which would lead to the ability to compile this fine because those definitions for those functions are given to me. So now, great. So what? Okay, so what happens if instead, supposing it's no longer week 1, week 2, it's now week 14, week 15, people are starting to take their studies a bit more seriously, although I hope you've done that sooner than that. But regardless, they might switch from drinking alcohol to something like maybe Red Bull, right? And so now, which is reasonable, and even from a programming standpoint, yeah, you swap out the things you use all the time, right? You swap out logic, right? And so what's the problem with this? Well, if we try to, after we make that change and we try to compile this, same process, right? If I include student.h, I copy everything that's there into here, I get redbull.h, I get the student definition, which allows me to declare Larry, but the thing is, at no point do I include alcohol anymore, and so I cannot do this, and so this would lead to a syntax error because I do not know what this is to even do in the first place. And so, while it might seem, oh, I'm just saving myself some trouble, I know that students will have alcohol, but that's not always going to be true. So never assume a header file will include something for you, ever. The correct path would have always had been, and I'll get there in a moment, to, if you're using it in this file, include it in this file, always, no exceptions, right? And so if you make assumptions, then you run into issues like we see here, right? And so if I had, at the beginning of this whole phase, included alcohol.h, then it's a non-issue, right? We would have never encountered any issues at all. As long as we consider something that I'm going to talk about in a little bit, but regardless, this is what you want to do. So include things, only include things when you need them, yeah, and nothing else, right? And so don't make assumptions. Anyways, so interesting point. It's actually a pretty important one, but I mean, you'll get some practice with this. Okay, so preprocessor directives. So let's talk about this. So there's a few of them. We know sharp include is one of them. There's also another one called define, and so this effectively allows us to create constants. Now we have to be careful. These are not variables. They are never variables and will never be treated like variables. And so let's see some examples, and we'll talk about the pitfalls of this in a moment, right? And so here in this file, it doesn't matter if it's filed.cpp or whatever. Here I am telling the preprocessor to associate the characters capital P, capital I with the series of numbers 3.1415 or the number 3.14159. And so effectively, after, again, so the preprocessor directives happens before compilation, so before we check for correctness of syntax. And so all this does, all the preprocessor does with this, it replaces every instance of P and I with 3.14159, a direct replacement prior to compilation. And so that is to say, when we get to the point where we, let me see if I can just kind of show it real quick. So preprocessor, if there's any sharp defines here, when we get to this part, at this stage, we no longer have any code with the letters P, I there. They all will be replaced with 3.14159. And it is as if you had just typed that there. In terms of what the compiler will see, it is as if you type those numbers there or that number there directly, right? So it is not a variable. It's simply something that happens prior to compilation with regards to constants and replacement of constants. And so now that isn't the only way in which we can use it, right? Yes, you can use it to find constants, although I'm going to say right off the bat right now, don't do it this way. If you need actual numerical constants or even other types of constants, don't do it this way. Just declare variable constants. That's always the safest way of doing things. So I would define float, const float, whatever, the identifier. I could still use pi 3.14159. That is always safest. This is something that's more common with legacy C code. And well, if you're interfacing with C code, then yeah, you might not have a choice. But regardless, if it's not something already done, don't do it, right? If you're using C++, just define constants. That way you get things like type checking, which is always the way you want to go. Anyways, and so now you don't always have to associate the preprocessor definition with an actual value. You can actually leave it blank, right? Because what this is doing effectively, when you go through, when you sharp define things, it creates essentially a table of all the things you're defining, right? And so it sees sharp define pi. It'll have a table where it says pi is associated with 3.14159, and subsequent to that, yes, it will replace all instances of pi with 3.14159. But also, you could do things like this: sharp define foobar with nothing associated with it. And in the table, you will see. Well, let me just do it if it's something that's a bit confusing, right? So suppose this is whatever. So the preprocessor directive table, right? And so at this stage, when the preprocessor sees this, it will say, okay, there's pi. There's also capital Y. There's also 3.1414159, and there's also foobar at second line, like that. And then it'll just fill this up with all the constants or the sharp defines it sees, right? And so right now we only have 2. And so it would say, okay, so these 2 are currently existing within the program. And so, you know, so what, right? And so this will only matter later on, which we'll see in just a moment. And so it fills up the table, and well, for circumstances like this, it'll make a replacement of pi with 3.14159. This is in fact a little bit more tricky in that it actually controls something else. And so we'll see how we use it in just a moment. For example, there are 2 additional preprocessor directives, if def, sharp and if. And so this is reminiscent of if statements. In fact, that's just all it is, but at the preprocessor level. And so effectively, the short of this is a lot of these preprocessor directives is effectively to control what will be compiled, right? So that is to say, we can use these questions or these statements to determine what is and is not included within the compilation unit. In particular, this is important when you're getting into cross-platform programming, right? And so the code that you need for, say, a Macintosh program versus a Windows program is going to be different because you're going to be using different libraries. And these are the mechanisms you'll be using in order to determine whether or not you want to use this version of this function versus another. And actually, your first project will have an example of this, but we'll get there in a moment. And so anyways, so first of all, how is this used? So first of all, this is checking your preprocessor table. Like for example, we see here that, okay, this is a different example. We see that foobar is defined. And so when it gets down to this line, it says, okay, if this thing has been defined, which it sees here, which it is, I will include this into what will be compiled, right? This will be thrown into the compilation unit. And so since this is defined, then boom, yeah, this is going to be included. And so we will see this version of some func in whatever is compiled. Now, if for whatever reason I delete this line, boom, right? And so that is to say I got rid of it from this table. We get to this line of code. It says, if this is defined, I will include this into what's compiled. But it's not defined. And so this will not be included in what will be compiled. And so effectively, this would have programmatically commented this out. All right, so boom, just like this. Right, exact same behavior. Okay, now, if you need a break to digest it, pause the video. And so there is actually the inverse question of if def, which is if end def, so if not defined. This actually ends up being the more useful logic. You'll see why in a moment. In fact, we're going to be using this quite heavily, but once you do it a few times, it's kind of like a once and done thing. You don't even have to think about it. In fact, this will be the mechanism that we employ that replaces the thing I'm telling you to delete pragma once, right? So pragma once does something. This is the way we're going to actually be doing that one thing. So let's just get there. All right, so here, let me go ahead and fill my table up with foobar. All right, let me go ahead and view always on top. All right, so foobar, right, so there it is. And so we see, here's the question. And so this is saying, if this constant has not been defined or thrown within the preprocessor table, then include this. But because at this stage, this is defined, that's saying we're not going to include this, right? So that would, now if we get rid of the constant, it's inverted logic, it's a pain, don't worry about it. The usage of this will make it clear in a moment. All right, so now if we get rid of the definition of the constant, sharp defined, we deleted that line, we see that, okay, since that's not defined, include this. And so this will then be incorporated into the compilation unit. Again, I think that the most difficult thing here is, well, first of all, understanding that there's this thing called a preprocessor, but again, it's just copy pasting stuff. And so now on top of that, it also routes or comments or uncomments things based on the constants you define, right? And so now, but you have two ways of doing it. You have the direct logic or the inverted logic. And unfortunately, the inverted logic is the way, is more useful in many regards. And so that's actually going to be the highlight of the next few set of slides. And so let's get there. Boom. Okay, and so separate compilation. So first of all, let's talk about a few things. So when using class composition, it helps to define each class in separate files, which I noted earlier, right? So for example, here's my class.h, or my calculator, right? And so its class definition, everything I need to know to use this object is inside the header file, and thus I can just need to include the header file in the situations in which I need to use a calculator. And so boom. Now in terms of its member function implementations, that must be done, or will, well, not must be, but is our convention we're adopting here, is that those implementations will be in a companion header file or source file CPP, right? So it'll look something like this, and we'll go through a lot of examples. Now, one thing I want to highlight again is the fact that because we pulled out the definition of the member functions outside the class definition, you must have the scope resolution operator to tell the compiler that this compute belongs to this calculator. Okay, and so this is a bit more clear than the destructor and constructor example, because it's a bit fuzzy because the names are the same and you see the same name on the same side. This should make it more clear, right? This is saying this implementation for compute is that scope is resolved to the calculator object, which is here. Okay, so hopefully that's a bit more clear than before. Okay, and so now if you have a student, here's the student definition. They are using a calculator, and so that means they need to know the definition of a calculator, because this is a full-blown calculator, right? A declaration of one. And so the way they do that is to include the header file for the calculator, which has the definition for a calculator. And so same thing, the class implementation for the student is in its companion CPP file, which, you know, it has study being part of the student class scope resolution. Oh, incidentally, since these have return values, remember destructors and constructors didn't have return values, and so you didn't see anything on the left hand side of this. But again, so the scope resolution is resolving the name, right? And the return value is sort of just thrown in where it would normally be before the name. Okay. And so in main, I can include student if I happen to be declaring a student, which I am. So here I declare a student. Let me flip the logic. I'm declaring a student here, so that means I need to know the student's definition, which is in the header file, student.h. And so I'm gonna have student study. Okay, and so now something interesting and something very bad happens here, and this will it will lead us to needing to control what will be compiled, and then we will make use of some of the preprocessor shenanigans we talked about earlier in order to facilitate that. But let's go ahead and get there, right? And so first of all, here, let's suppose in main I both want to have a student in main as well as a calculator. And so logic, or our conventions dictate, again, if you're using a thing, include the thing, right? So here I'm using a student, I include a student, or rather I need to know its definition, which is in the student.h. Here I'm using a calculator, so I must provide to main the definition of calculator, which is in the header file, so I include that. Okay, so this is fine, but now because we have yet to do a few things, this actually leads to an issue that we're going to address afterwards, right? And so let's go ahead and go through the preprocessor process and copy pasta stuff into where they belong, right? So boom, let me create some space. So here we go. We see a preprocessor directive, sharp include student.h, and all that's saying copy pasta this here. Let's do it. Boom. So copy pasted. All right, so I moved this over here. Now we go down, we take a look. Oh, I see a include calc.h, copy pasta. Boom. And now we look through preprocessor directives. I see one here. Let's go ahead and replace that. Boom. And I look through this, I don't see any more hashtags, so it looks like this is completely pre-processed. And so let's go ahead and throw this to the compiler. Okay, oh, what's the problem though? All right, so if I go ahead and try to figure this out, what do we notice? Definition, both calculators. Which one do I want? Right, again, the computer is not smart enough to know that these are the same, right? And so we have to, well, this is a problem. This is an issue of multiple definitions. And so effectively, we can't move forward. But what this leads us to think about is, well, how do we prevent one of these from being included after we include the first one, right? So how do we control that? Well, we have some preprocessor directives. And so maybe we can use that to flip a flag when we include something. And so we can check for that flag to see that we included it. And so we can stop any additional or subsequent inclusions after that fact. That's exactly what we're going to do. And so let's go ahead and fix things. And so the fix is this. And so we need to use what we call header guards, right? And so again, if you're paying attention at that point, when you in Visual Studio and some other IDEs, they will automatically populate your header files with pragma once. The pragma once effectively serves the same purpose, but it does it differently. And you'll come across problems when you have multiple directories with the same file names, which I will have because everything I have, 100 students, all of them are submitting to me the same files, and if all of them are using a pragma once, I will not be able to compile anything because they're all going to be in different folders. And so please delete pragma once. It will not work with my grading scheme. Regardless, what you will be doing instead, and is part of the standard definition of C++, where pragma once again is not part of standard yet. Again, there's a push for it, but I think there's enough of a drawback to it that it's just not something that they feel comfortable forcing upon the standard. So anyways, regardless, here's how you do it, right? We have include guards. So this is what you will do every single time for your header files. So first of all, we check to see if a certain constant has been defined. It doesn't matter what you put here. It could be anything as long as it's unique, right? And so I could say, okay, the convention that's being used here and is often used is just use the header file name, and instead of a dot, use an underscore. Now, you might need to be a bit more clever than that because you might have a bunch of header files that have the same name in them. And so you could say something like, CS20 project 1 underscore calc underscore h, right? Something to make it unique. That's the only thing that matters. And so we check to see if that has been defined. If it hasn't been defined, we go ahead and define it. Okay, and so the only thing that matters here is that we use the same identifier effectively, right? So calc underscore h, calc underscore h. These will always be the very first two lines of all your header files. Okay, and so now that is to say, all the code that would have normally been in or it will be in your header file, the end of it will be enddiv, right? So these are the very first two lines. This is the very last line, period. There's nothing before this. There's nothing after this. Okay, easy peasy. And again, the only other thing is that these must be the same, otherwise this doesn't work, and you'll see why in a moment. Okay, and so now we do the same thing for student, right? So if this constant hasn't been defined, we're going to define it, very first two lines of the file, and at the very end, this. And everything else is in between. Okay, so again, to reiterate, if n define some constant, define that exact constant, the very first two lines of all your header files. A bunch of code, the code that would have normally gone here in the first place, or all the code that is in this file, and then at the very end, and the if to close it all off. So that is to say, this resides, any code whatsoever will always reside between the header guards. All right, and so sometimes people get a little bit confused and they throw like inclusions up here. I mean, you might be able to get away with it, but why? Why sort of avoid the header guards when you want the header guards to protect you, right? So everything in between the header guards. Okay, you'll get plenty of examples. Well, you have a project for sure. So, okay, let's see how this fixes the problem that we saw earlier when we had multiple inclusions. And so what I did here is I did exactly the same thing we saw with the previous slides. I just copied everything in here. Now, if you're kind of confused how I got to the point, just be the preprocessor, right? Go to your main, right? Go to your main before this point, which is this, and then use the change calc.h and student.h on the next slide and copy pasta into here. You'll get exactly this. You'll get exactly this, right? And so just do it if you're confused. And so presumably you did that. We have this. Let's go ahead and go through the preprocessor phase. And so I'd see, oh, here's our preprocessor directive. I asked myself, well, let me go ahead and throw, here it is, right? Well, I'm going to have it actually here, so it doesn't really matter. So here, the table's over here. We ask ourselves, has we defined this yet? Or have we defined this yet? I'm going to get fired. So have we defined this yet? No. And so I don't see it in my preprocessor table. And so we go ahead and jump into the body of this, which actually goes all the way from here to, looks like, I think, here. Anyways, so we include all of this within the compilation unit. We go ahead and define the constant. Let me go ahead. So not define, so we include this. We define the constant, so let's go ahead and throw this into the table. We go down here, we see another question. Have we defined calc underscore h yet? Answer is no. So we can include all of this. And so what's included is the fact that we need to define this, and so go ahead and do it. Boom. So now we have two constants defined. We can go ahead. So this will certainly be included into what is compiled. We get down to here, we're done with this. Boom. Okay, so now we get down to here, we're done with this. Boom. So all of this is included. We get down to here, we ask the question, is calc underscore not defined? Well, it is defined, and so we don't do anything between here and here. This is effectively commented out because it is defined. And so, boom, get rid of it. Not compiled. And now we end this, and so that effectively kills all the way up to here. We remove all of those commands. We're left with this, and we see that there's only one definition for a calculator, and so we don't have an issue. Okay, so header guards prevent multiple inclusions. Okay, so now let's go ahead and take a look at when we need to include things. Well, again, the base of it is you need to know the definition of an object if you're using the object in any meaningful way, right? If you're declaring an object or using it, you need to know the object, and that leads to the fact that it means we need to include its header file because the convention we're adopting is that the definitions are in the header files. Okay, and so now let's take a look at a few things, right? And so here I have, well, I'm using alcohol. It's a pointer to a bottle, and so you might be tempted to say, well, look, I'm using an alcohol thing, and so let's include it. You can, but there will be circumstances in which this will actually lead to issues, but we'll get there. All right, so boom. Boom. Anyways, and so before we get to that example, let's go ahead and put down the various circumstances in which you need to do one or the other thing. That is to say, include the definition or not. And so when you don't need to include it, you have to do something else, but we'll get there in a little bit. So here, you must include the header file, or you must provide the definition of the object when, for example, we declare such a type of thing, right? That should make sense, right? If I'm declaring such a thing exists, I need to know what that thing is, right? So if I'm declaring X of being a first class type, I need to know what that is in order to do this, right? Because this is a first class thing, and so I must know the object defined in this file. Okay? Same thing here. If in this class definition, and well, also because I have the function implementations in the class definition, because I am declaring a first class Y here, that necessitates the need of the class definition for a first class, which is inside a.h. Boom, same thing. This is just 10 times worse, right? This is 10 of them, right? So I need to know it 10 times over. Same business. Again, this is even a worse case than this, because not only do I need to know the thing here, I need to know how to use it, which is here, because I'm invoking one of its functions. And then if I want to return it, well, first of all, I would need to have a return value of first class type here, but that's besides the point. But because I'm returning that thing, I need to know what to return. And so that means I need to know its definition, which is in a.h. Okay. So again, the short of this is you need to know the definition if you declare the thing or use it in any way, right? Boom. Of course, this does changes things a bit if you're talking about two different files. Like if I separated b.h with b.cpp, but just be aware. I'll go through an example if we have the time. Okay, and so now, if you didn't do any of those things, none of those things whatsoever, if you use these sequence of characters as a parameter, you add to a function, you do not need to know the definition. Because again, recall, a function doesn't do anything. A function does absolutely nothing. It's only a pattern for behavior. It isn't until you actually invoke this function, goober, for example, in which you would then need to know what first class is. But we're not doing anything with goober yet. We're just saying goober exists. And so just saying a function exists with this type of object does not require the definition because you're not using it. Okay, now you need to do something else, obviously. You need to reserve the name, if you recall. But we'll talk about how that works out with classes in a moment. Boom, same thing. Return type is just same thing as a input parameter, right? And so we're just sending it out to whoever called this function. Again, this Huber function is not doing anything right now. This is just saying I have the ability to call Huber. I'm not actually using it yet, and so we don't need to know the definition per se. And then, so this is sort of, I made the statements to this effect. So pointers are not things themselves ever. And references are kind of the same thing, right? They're not things. They're not this thing. It's a reference to a thing. This is a pointer to a thing. They are not things. And so they don't have constructors. They don't have destructors. They don't have anything. We'll see in a moment what they are, but they don't have anything. They're not objects. And so you don't need to know their definition because of that. And so that means I don't need the definition to declare a pointer of first class in this example, or even an array of pointers of this type, because none of them are things for which a definition is required. And so, and the same thing here within the function. This is just a weaker form of this, right? A first class pointer. Pointers are not things. They have no definitions required. Well, in and of themselves. Now, pointers, if you do something with down the line, which we'll see in a moment, yeah, presumably we may need to know the definition at that point. But what we see here, we're not using first class in any way whatsoever. We don't need to know its definition. Instead, in all of these circumstances, you just need to tell the compiler that such name exists. You need to inform them, you need to reserve the name first class. That's it, because this is a reservation, right? You're not actually sitting at the table eating just yet. And so the manner in which we do that is to declare first class. And so it's a little bit different than function declarations because, well, we know what functions look like. Here, you just have to say class first class. And this is saying to the compiler that such a name is reserved, and this is enough in the case in which, well, we're not doing anything with the thing itself. Right? And so you might hear in some places they use the term forward declaration. I might even trip up and say it from time to time. There's nothing specific about this forward declaration. There is no such thing as a forward declaration. It's just a declaration. But you might hear it because they think like this is happening forward. This is forwarding this name, or just know that they use that from time to time. But they're just saying declaration, and they're just doing this. Okay. So a lot of things, and again, this will become more clear when you see examples, which you will get plenty of. Okay, so now, so there's a few things to consider here, right? And so none of these circumstances actually use first class, right? So just convince yourself of that. None of these use it, and so we don't need to know the thing. We just need to know its name, so we declare it. So boom. Now here, why not just always include it? It turns out that, well, sometimes you can. Sometimes you can get away with it. But as you begin establishing more complex relationships between your objects, you will encounter circumstances in which things are somewhat cyclic, right? Things are referring to each other, and when you have that relationship, it will end up, well, you won't be able to compile, right? You'll see in a moment. That's actually the next example, but regardless. So first of all, before you even get to that, again, so for many of you, you haven't really worked on anything significant in size, and so the time it takes for you to compile your code is not significant at all, right? Like maybe a few seconds. Easily, when we're talking about anything more than maybe 20-30,000 lines of code, we're talking minutes. And even depending on other things that you're dealing with, we can talk about hours, even days, depending on, again, other factors. And so days is a bit much, like half a day, but still like a long time. Just think about your workflow, right? And so I've already suggested to you that you need to be testing or verifying all the time. But imagine instead of being able to type and verify, compile, whatever, you needed to wait minutes between. Like that's killing your productivity by more than several thousand-fold, right? And so, yeah, it's a big deal once you start working with anything, non-trivial. And so, yeah, you want to have rigid, or not rigid, but strict control over what you include, right? You don't want to be like, I want to include all the things because I'm lazy, right? You will get reprimanded pretty quickly if that's your policy. With your first job, right? Because it's just kind of, people are gonna like see like, what the heck is this? Why am I taking 20 minutes to compile when it should only be 5, right? So this is a thing, be aware of it. I mean, you're not gonna experience it in this class because I'm not giving you things that are 80,000 lines big, but it can be an issue. So now, so here's the thing I was kind of alluding to. You can and probably will encounter cyclical relationships, right? And so let's see what that is. So, for example, let's take a look at just the high-level scenario, and then we'll try to interpret it or implement it by way of a program, right? And so suppose we have students in classrooms, right? So here's some students, so bright-eyed, naive, wanting to learn, right? Not jaded. And then here's the classes, right? We have CS20 and art history, right? And so clearly, in terms of just the relationships, right? This sort of actor relationship, we see that students, clearly, they should know what classrooms they're in, right? So I know that classroom, I know that classroom, I'm in it. And so each classroom probably maintains a roster of the students that are there, right? And so I might have a little sheet of the attendance or whatever, right? So enrollment. So boom. And so now let's go ahead and see how we can implement this within the program. Okay, so here we have a classroom class that holds a bunch of students. So boom, right? And so I have classroom. Here I define an array of potentially 100 students. Okay, so we're just saying I have 100 seats, although this is more reminiscent when this was something, of course, that was done on campus, but I think we can stretch our imaginations and remember such a time in our lives. And so here I have 100 students, and so an array of students, which means I need to know the definition, which means I need to have the header file. So great. And then inside the CPV file, I might print the roster, which goes through and has their student call their name and whatnot. And now, incidentally, anyways, yeah. So there's that. So now let's talk about the students. All right, so here's a student. They have a pointer to a classroom. And so this is an interesting design choice, which I like, right? Because if you think about it, if we're defining a thing itself, that's kind of like saying a classroom has students within it, right? So we actually have space for students. Whereas this is saying this is not quite a classroom, but rather something that points to a classroom. Now, again, we haven't talked about the details, but I think the language sort of explains it well enough to understand the example, right? So this isn't a classroom, but this is just saying a student has the ability to know which classroom that they are part of, right? And so, anyways, again, pointers won't be until next week or week after next. And so, regardless, excuse me, tacos. Okay, so so here we are including the classroom. Okay, I mean, seemingly there's nothing wrong with that. This certainly allows me to declare a pointer. It might lead to some issues, but let's see. And again, within here, we see that a student can print a classroom in which they can get the classroom and have it get its number. Don't worry about the syntax. But this is presumably using the classroom, right? So certainly at some point, this will need the definition for a classroom, which we're kind of getting through student classroom here, but all besides the point. Okay, let's analyze this. All right, so the classroom includes a student because it has students. And here we are including classroom because, well, we're using a classroom name here. Now, we sort of hinted earlier that this might not be necessary, but certainly we can do it, maybe. But in and of itself, it's not a problem, right? So clearly, declaring a name is certainly, well, including the thing itself does provide the name, right? So this will certainly allow us to do this, but whether or not this leads to other issues downstream is what we're going to examine. And so now, so let's go. Oh yeah, we're going through the copy pasta process, right? So here's my main. Let me go back. So here I have a student David, right? And that's all I have, just a student David. And now let's compile this and pretend we're the preprocessor. So we copy paste everything in student.h into main.cpp. There it is. And then we include everything in classroom.h into student.h or into main.cpp. And then we include student.h or what's in that file into main.cpp. Then we include everything that's in classroom.h into main.cpp. So I think you see it, right? And so this is an issue, and it turns out the nature in which these things are being done, header guards do not prevent this, right? And so that won't fix this problem altogether. And so how do we fix this? Well, first of all, we need to redesign to a certain extent. And so let's take a look at our header files, or the classroom, or the student and classroom definitions, which are in the respective header files. We need to identify a circumstance in which we don't need to include the thing, right? And so here, obviously, if this is the way we choose to implement this, we need the definition, because if we want an array of students, we need to know students. Whereas, I mean, it was kind of given to us that this was a pointer to classroom, not a classroom itself. It's just a pointer, and so we don't need to know the definition of a classroom. And so we can simply demote this from a full-blown definition to just the declaration. And this is enough to let the compiler move forward. And because the classroom.cpp exists, it will link the appropriate thing when we actually put things together with the linker phase, right? And so maybe you remember that, maybe you don't. It's okay if you don't. Just know that, again, compilation, you only need to know names. Linking is when things are put together. And so, anyways, and so now, incidentally, if we go back here and if this was a slightly meaner example and maybe we didn't make this a pointer, right? So that would have been a problem, because if this wasn't a pointer, we would not be able to declare it, because a non-pointer requires us to know the object. And so the fix there would have been to make one of these things pointers, which you can always do, right? I could always make this a pointer. It does. I mean, I don't want to say it complicates things. It just makes things different, right? And so you can always do that. And so, boom. Anyways, but that's not the example. Okay, and from that, there's just a few things just to make sure we understand the consequences of doing this, or the implications rather. Right, and so if, for example, like this is sort of tying back to that last thing I was just talking about. If for whatever reason we do this would break everything, right? Because this would necessitate, if this is what we wanted, this would necessitate including the entire definition, right? And so we would replace this with include.ation, the whole thing, or include classroom.ation. That would just muck everything up again. And so the fix would be to just not do this, or make this a pointer as well. All right, that's the only way to avoid that particular situation in this example. Boom. Anyways, so yeah, just be aware. Incidentally, also, if for whatever reason, like, well, first of all, to reconcile the fact that we included or declared here, because indeed we're using some of the classroom functionality here, we actually need to include classroom.h here, which, I mean, to me, I would have done that off the bat regardless, right? Even though I know for a fact that, yes, because these two are linked, this will always include what's in here, but it doesn't hurt to do it again here. You don't lose anything because you have header guards, right? Header guards will prevent anything from going awry in that regard. So I would have just done this right off the bat regardless. Anyways, so there it is. Easy peasy. Lemon squeezy. So now, a few last things, right? So finally, make sure that your class doesn't have any other members or functions that violate everything we just talked about, which should be obvious. I mean, it'll break otherwise. Like, for example, I mean, this doesn't make any sense logistically because, I mean, if you have a CPP file with the definitions of the member function implementations, this would never be here, right? But if for whatever reason you just, I don't know, just decide to throw this here, obviously this would break it because this requires a definition, which you can't have here. Well, which you can't have in the grand scheme of things. I mean, it can be here, but that would mean this would need to be a full inclusion or the definition. But I mean, it's a non-issue because this would have gone into the CPP file anyways. And so, yeah. And so the actual usage of the classroom isn't here, but rather here. So I don't know, a weird example. So that fixes it, and that's it. And so, yeah, so that's that. I will have some examples to go through all of this. In fact, your first project will be on just doing this exact thing, right? I'm going to give you a file, and you're going to split it up into 13 files. And so it's going to be, it's easy if you do it right. It is impossible if you do it wrong. And what tells you what's right and what's wrong is this idea of making small changes. Right, and so I'll talk more on that when I release it and whatnot. But just be aware. But once you do it, it's easy. Like, you just need to get it out of the way, suffer through it once, and then it's straightforward enough that it's something that you're gonna get pretty quickly, and it won't be a problem for the rest of your life. But you just have to suffer it at least once. All right, well, that is, I think, everything I want to talk about.